This is the IP-SLA reachability lab. This network uses HSRP, where router 1 is the active and router 2 is the standby for VLAN 1. Router 1 and 2 advertise the same network into router 3. The problem here with this design happens that if distribution 1 switch gets misconfigured, it can probably make router 1 get disconnected from VLAN 1, but router 1 will not be able to know that because its interface gigabit 10 will not come down, so router 1 will still be advertising the prefix into OSPF into the OSPF autonomous system. Let's see what this means. Currently, router 3 believes that this prefix is reachable through router 1, and right now it is working. But what happens if distribution 1 we misconfigure it and set VLAN 2 for router 1. So router 1 will be actually getting disconnected from the network. But router 1 has no way to know it because the interface gigabit 10 is still up. So router 1 will still be advertising this network into the OSPF domain. So router 3 still believes that this network is reachable through this next hop, which will be wrong. So we're going to configure router 1 in such a way that it can tell when something goes wrong. And we are going to use IP-SLA. So let's configure IP-SLA 100. For instance, it can be any number. Then we're going to use one of the operations to work with reachability, which can be ICMP echo, and we're going to ping the distribution switch. For this operation, we're going to set threshold of 600 milliseconds, a timeout of 700 milliseconds, and a frequency of 1 second. So this SLA will be working every 1 second and will be consider that it will stop waiting for an answer after 700 seconds, and it will consider to be failed after 600 seconds. So let's start the SLA. I now just configured, so we have to start it up with IP-SLA schedule, SLA number 100, start time now, live forever. Now we can see the status of the SLA. It is returning a code of OK because we can reach the switch. Number of successes is 8. It has been doing it 8 times so far. Okay, now we're going to create an object. Track 1 IP-SLA 100, and it will be a reachability type, and I will consider to be down if this IP-SLA remains down for 30 seconds, and and down if the IP-SLA remains down for 30 seconds. So I am using this because I want to avoid glitches on the network, so I will be avoiding false positives testing. So if for any reason in the network router 1 stops switch to D1, I don't want to do anything unless if it stops reaching the distribution 1 for 30 seconds continuously. So I have a tracking object, so I also need an applet that will be doing the actual change on the configuration. So I will use event manager. So what happens if If distribution 1 goes down, I will have to link this applet with object 1. If the state is down, I will take some action. Action number 0 will be entering the command enable. Action number 2 will be entering the command conft. Action number 3 will be entering the command interface gigabit10, and action number 4 will be entering the command no IP OSPF1 area 0. I will have to create another applet when the distribution 1 comes up. I will have to restore the config. I will drag the same object, but if it comes up, I will do an enable, then a conft, then I want to interface with 1, and I will have to enable OSPF. Okay. So we can track how many times these applets have run. Event manager history events, they have not run yet. It is okay, and the SLA is okay, and the tracking show track 1 is up. We can now that this object is tracked by these two applets here. So let's tear down the communication between router 1 and the network. Let's simulate misconfiguration in distribution 1. Switchboard X. So now I enter VLAN 2, so router 1 becomes isolated. So the SLA established that a timeout is found. The tracking object is starting a countdown of 30 seconds, so we can avoid false positives. So we should stop seeing the distribution 1 for 30 seconds in order to take action. Now it changed to state down, and now this applet was run, D2.1 down, and then we should be able to see that the configuration is changed. No more OSPF, and here we see that we can reach this network through another next hop. So let's restore. So now it works. So now let's store the configuration to see what happens when it restores. Now the SLA should come up. It will take some time because of the simulation in order to come up again. Okay, the SLA came up. The tracking object will take 30 seconds in order to come up because it has to make sure that the SLA remains up for 30 seconds to avoid network glitches. And when it's come up, this applet should be run. Okay, now let's see what happens with the tracking, with the event manager history. Now this applet was run, and the configuration should be restored. This command was entered, so now router 3 should have a correct next hop. Okay, that's it.